Hi everyone, today I'm excited to present our work titled Overexposed HDR Reconstruction Boosting with Training-Free and Exposure-Consistent Diffusion. This research conducted at National Yangming Jiao Tong University and MediaTek addresses the critical challenge of restoring details in overexposed regions of high dynamic range images. Here is our outline. Let's look at the dynamic range. It represents the ratio between the largest and smallest measurable values in an image. Standard LDR images often fail to capture the full irradiance of a scene, leading to loss of information in either extreme shadows or bright highlights. The core problem is overexposure. When highlights exceed the camera's sensor capacity, details are clipped and lost. As you can see in this exposure variance, EV0 to EV-2, the detail visible in lower exposures are completely missing in the standard EV0 capture. Our key idea is to impede these overexposed regions. We want to generate plausible, high-frequency details at lower exposure values where information was lost, effectively extending the dynamic range beyond what was originally captured by the sensor. One of the strengths of our approach is its versatility. It can be used to boost any existing single-image HDR reconstruction method, whether there are indirect methods that generate stacks or direct methods that output HDR content immediately. We utilize SD edit within our impending pipeline. This allows us to preserve existing information from previous iterations while adding realistic textures. By using diffusion priors, we can hallucinate details that are semantically consistent with the rest of the scene. To maintain exposure consistency, we develop a compensation pipeline. We calculate a residual based on the difference between the aligned LDRs and a calculated lower bound of luminance. This ensures the generated regions blend naturally with the original unclipped areas. Our approach isn't a single pass. We use iterative refinements, repeating the cycles of impending, merging, and compensation. This step-by-step process gradually recovers fine details in the most severely overexposed regions while maintaining global image coherence. Here's our experimental results. The table is organized by baseline methods, such as direct methods, single HDR, and glow gain, and indirect methods, deep recursive HDRI, multiple exposure generation, and CEVR. On the left, we have non-reference-based metrics, which assess the inherent quality of the image without needing a ground truth. And on the right-hand side, we have reference-based metrics, specifically KID and HDR VDP3. Our methods outperform all the baseline in all the non-reference-based metrics. And for the right-hand side, since the original signals are completely lost, sometimes we need to sacrifice the reference-based score, while baseline methods usually just fill the white blank into the overexposed regions in order to gain a better reference-based performance. Here we see a qualitative comparison. Notice how the baseline methods often struggle with color shifts or lack of detail in the share. When our method is applied, the highlights are recovered with much more realistic captures and consistent exposure. In conclusion, we have presented a training-free diffusion-based pipeline for boosting HDR reconstruction. Our method effectively restores overexposed regions by leveraging diffusion priors and a novel compensation strategy to maintain exposure consistency across the image. Here's the research. Thank you for your attention.